In this video, we're going to discuss the Pythagorean identity. In particular, we're going to use the unit circle to derive the basic Pythagorean identity and use it to find the sine or cosine of an angle given the value of the other function and the quadrant of that angle. We begin by recalling that the equation of the unit circle is x squared plus y squared equals 1. This means that for any point that lies on the unit circle, if we take the x and y coordinate of those points, substitute them into the equation for x and y respectively, we'll obtain a true equation. In particular, we know that for any angle theta, the point cosine theta, sine theta, is a point on the unit circle, and therefore, if we substitute in the cosine theta for x and the sine theta for y, we'll obtain a true equation. When we do that, what we obtain is the equation cosine squared theta plus sine squared theta equals 1. This equation is true for any angle theta, whether it be acute or obtuse or even negative. For any angle theta, cosine squared of theta plus sine squared of theta will always equal 1. This equation is so well known and so useful in a variety of ways that we're going to give it a name and call it a Pythagorean identity. There will be some other equations that will also be called Pythagorean identities later on, but these will all be equations that get derived from this particular equation. There is one piece of notation that deserves some discussion about this equation, and that is what exactly we mean by cosine squared of theta. This is something that is very customarily done with trig functions to try to avoid confusion. The expression cosine squared of theta is going to mean the cosine of theta quantity squared. In particular, if we have our angle theta, we're going to take the cosine of the angle first and then square the resulting value. What we're not going to do is square theta first and then take the cosine of that squared angle. This will typically give us a very different value, and so it's important that whenever we write cosine squared of theta, we are going to take the cosine first and then square the result. The same note applies to all other trig functions. For example, in the same equation, we have sine squared theta. We're going here to compute sine of theta first and then square that result. One of the useful aspects of the Pythagorean identity is that it allows us to convert between sine of theta and cosine of theta. In this example, we're given that sine of theta is 3/7 and that theta is an angle in quadrant 2. And we'd like to find the value of cosine theta. So we can start here by looking at and considering the Pythagorean identity, cosine squared theta plus sine squared theta equals 1. We're given the value of sine of theta, so we can substitute that into this equation to obtain cosine squared theta plus 3/7 squared, and that'll have to equal 1. We do some arithmetic here, and we can solve for cosine of theta. So cosine squared of theta plus 9/49 will equal 1. We can subtract 9/49 from both sides to obtain cosine squared theta equals 40/49. And finally, we can take the square root of both sides and see that cosine of theta is plus or minus the square root of 40/49. And if we wanted to, we can simplify this a little bit. This will be the plus or minus square root of 40 all over 7, since the square root of 49 is 7. Notice that the plus or minus here is incredibly important. When we solve this equation by taking square roots, we always have two solutions. And it's going to be up to us to determine whether we will want the positive square root of 40 or the negative square root of 40 in our answer. To figure that out, we're going to consider the quadrant that we're told our angle is in. So here our angle theta is in quadrant 2. So if we sort of sketch a unit circle here and an angle in standard position where the terminal side is in quadrant 2, something like this, what we see is that our point of intersection is here, and the coordinates of this point we know will be cosine theta, comma sine theta. In particular, the cosine theta is our x value, and by looking at that point, because we're in quadrant 2, we know that the x coordinate of that point will be negative. And therefore, we have to choose the negative square root for our cosine value, so that the x coordinate of our point will be equal to this cosine. So, after all this, we can conclude that the cosine of this angle theta is going to be negative square root 40 divided by 7. If you'd like to practice with a similar problem, try to find the value of sine theta if we know that cosine theta is equal to 5/8 and that theta is in quadrant 4. The correct answer will appear in a few seconds. So sine of theta will be negative square root 39 divided by 8. If we substitute 5/8 into the Pythagorean identity and solve for sine of theta using similar algebra to the previous example, we'll obtain plus or minus square root 39 over 8. In this case, theta is in quadrant 4, and in quadrant 4, the y value of all points will be negative. Since the sine of theta is the y value of the point on the unit circle in quadrant 4, the sine of theta must be a negative value, and therefore we choose the negative square root of 39 over 8.